So my name is Grzegorz Piwowarek. I'm working in Warsaw, in Poland, in a company called Talk. We are a software house. We have some small products, but mostly we write custom software. I'm also a yo-yo player, as you probably noticed. I used to be a professional one, but now I retired. And a musician, but let's keep this over. You can find me on Twitter, GitHub, and everywhere like this. You can find me on Battle.net too, and if you want to get kicked in Overwatch, you are welcome. Okay, so let's get back to the essence of this talk. Java 8. Java 8 was a very special release because it brought some ideas from the outer world to Java, from the world of functional programming. Actually we've been waiting quite a long time, quite a few years for this release, and people were very excited about the functionness of the new release. But unfortunately, after some time, people started noticing that functionness of Java 8 consists mostly of lambda expressions and few functional control structures like optional stream, completable future, and not really much more. Basically, people also started noticing that functional programming in Java 8 starts to look pretty much like this. And people started noticing more and more problems and lags when it comes to functionness of Java. And one of those lags were like that we had only 3 functional control structures, and Scala has like twice as much as those. There was no memorization. And now, the guys, don't worry if you don't know those terms, everything will be explained. Just assume that it's something that you can't live without. There was no partial function lifting, there was no pattern matching, no tuples. Optional for some reason wasn't serializable nor iterable, and due to the very noble crusade of assuming backwards compatibility, stream and optionals were present in some parts of the new APIs, but in old ones, it still needed to stay as it was. So, for example, when we were obtaining values from a map, we still could get a null instead of an optional. Also, checked exceptions in functions were pretty painful, and some people were complaining that there was an issue called type pollution, which means that we didn't have a one function type for representing all kinds of functions, but we had functions by functions, consumers by functions, unary operators, binary operators by functions, by predicates, and so on and so on. Some people found it confusing, and that probably could have been implemented in much easier way. So, for example, if you wanted to perform simple mapping on a list, you would need to write this. Oh, you can't see this. You would need to write stream dot map and then collect to list instead of just performing simple one map call. There are much more issues, but let's focus only on those. So before we go into the essence, into the Javaslang, I'd like us to ask you to just have a look at this method and just think about it for a minute. Okay, we don't have time, so let it be 1 second. Okay, you see this function signature, and you probably have some expectations. What could happen inside? Okay, you have a list of parameters, you have an output, you have a name, you have certain expectations. And I allowed myself to implement this one. And let's have a look. So there are many things very, very wrong. We are basically modifying everything that's possible: internal state, external state, modifying inputs, and so on and so on. So basically, this is the problem often when it comes to imperative code and code that operates on mutable structures and side effects. That we write methods, we define some parameters, but actually there exist much more potential inputs that kind of influence the outcome of our functions. So every time we write a function, usually it's not the declared input is not the only one, because the result might depend on an instance state, might depend on the global state, And if they somehow influence the outcome of the function, we still should basically consider them as valid inputs. But in such situations, they are not defined, okay? So they are somewhere out there, somewhere in the background, influence the output, but it's not clearly defined, so it causes some problems, especially when debugging. Okay, so also besides inputs, we can modify a lot of stuff. Of course, we can modify external state, internal state. We can mess around the whole world with one function, and this causes potentially some problems because sometimes you find it very, very hard to debug, and if you compose such solutions, such methods, there are small problems, small nuances that blow up in the most unexpected moments. And when you combine functions like this, those problems kind of accumulate and might explode in the really unwanted moments. So basically, in functional programming, this is what we want to achieve: that when we have potentially when we have inputs, we have outputs, and the result is like directly connected straight to the defined input and not influenced by anything from the outer world. Yeah, and this is the main point of today's talk, because many people assume that somehow I feel like this, that people assume that the functionness of some language is defined by the presence of lambda expressions, but that couldn't be further from the truth. Lambda expressions is a nice way of defining behaviors, but it's not the main thing of functional programming. Actually, functional programming is more about building small blocks of code, using small blocks of code that work, okay? When you have small and pure functions, and when you compose those small solutions together, you are very likely to end up with something that eventually works the first time when you try it. This is also why people say that when you implement something in Scala in a functional way or in Haskell in a functional way, it ends up working. But when you are playing with mutability and side effects and other stuff like this, when you compose all those functions, they usually explode in very unexpected moments. So there are two terms that I want to reference today for the future of this talk. Immutability, which means that when we have objects, when we create them, those can be modified after creation, and referential transparency. Referential transparency is a characteristic of a function, and it can be explained in an easy way, that when we have certain inputs and we run this function, when we call this function for this particular input multiple times, every time we get exactly the same result, and we don't perform any side effects, don't modify anything from the outside world, and don't take any hidden inputs from the outside world. And of course, I wanted to say one more thing, that actually some people consider functional programmers see them as they are on a constant crusade against mutability and side effects. And there are also many times you could hear arguments that you can't actually program without mutability and side effects. And the goal of functional programming is not to get rid of it completely. It's not to be on a holy crusade against those two things, but it's all about encapsulating them, those things, in such a way that we do not need to directly deal with problems they cause. Okay, so as we know, the lambda expressions are not something that determines if a language allows you to program functionally, but actually we need some tools for this. It's really hard to program functionally without proper tools. So for example, if we have a look at the Java Collections API, we can notice that there are many methods like add, remove, clear that do not return new instance. They might return booleans, they might return void, which means that they modify somehow internal state and embrace mutability. So this is the biggest idea behind Java Collections API, and as you can see, this causes some problems because it's really hard to avoid those structures if you are writing code, and it makes really hard to implement functional programming ideas. So for example, this is an example of when we are using hash set, we are putting some objects inside. After putting them to a set, we are modifying it. And somehow at this point we are losing the object's identity. And good luck, because good luck with debugging this, because it happens all the time. Okay, those are very easy things. They are very trivial things that we can forget about while programming. If you are building stuff, if you are using mutable objects, some problems like this never exist. Okay, because for example, hash codes can be implemented when can be calculated basically during when object is creating. Okay, so this is where JavaSlang comes into play. JavaSlang is this is what it is. Pretty scary, isn't it? JavaSlang comes here and helps us, provides us right tools to program functionally in Java. It fills in all those blanks that were left in Java 8. So let's see what it is actually. By the way, do you like the logo? Yeah, we're actually somehow our company managed to like engage into helping Daniel Dietrich in materializing his thoughts, and we helped actually created this logo, helping in creating these logos and providing some stickers. So if you want later, come here. There are many JavaSlang goodies for you all. Okay, so when it comes to the JavaSlang, there are three basic building blocks. We have lambda, we have tuple, and a value. Lambda is a set of functional, it's like a super class for the set of functional interfaces, a new set of functional interfacing on steroids. Tuple is like a way of temporal coupling objects together. Sometimes in our code we have situations where we need to couple, hold together a few objects, but let's say that this use case doesn't really deserve a new class to be created for this reason. In such moment we can use a tuple. And there's a value. The value in functional programming is very special. In true functional programming, we don't have variables. This term doesn't really exist. We are operating on values. So if we have, let's say, integer of 2, integer of 3, there are no situation where 2 becomes 3, okay? The state never changes, but we can evaluate some expression and get 3 out of 2. This is this is actually small, but a very meaningful difference. So all values are immutable. And now let's have a look at functional interfaces in JavaSlang. So as you can see, it looks pretty similar to what you can find in Java. But you can notice here that at the end of the class name, we have a 2. This is a number that signifies the arity of function. So in Java, you need to remember like all those fancy names for different functions that accept different amount of arguments. Here, all of them are named using the one convention that you have function name and then arity of a function, and this is nice. Also, it was a big pain to deal with checked exceptions because all functional interfaces in Java, they didn't have a throws clause in the function signature, which could be very, very painful because every time you encountered a checked exception in some of Lambda's body, you would need to manually try and catch it and usually just swipe it under the carpet by wrapping it into runtime exception or just logging a mistake. So here, for every functional interface, you have a checked interface which can throw checked exceptions. Okay, and all those functional interfaces, they can be composed together. This is basically just the same way as is done in Java, but except for composing them together, you can perform lifting on partial functions. We'll get to this. We can perform carrying and memorize those functions. What does it mean? Partial functions are functions that do not produce valid results for some inputs. So in a programming world, it usually means that they throw some exceptions. So let's create a function that throws an exception for one particular set of inputs. In this case, it's division by 0. So lifting changes partial function into a normal function, but changes the return type. When performing lifting, the return type becomes wrapped into an optional. So such function, when some exception gets thrown, the empty optional gets returned. And if everything went correctly, you have a normal option with a value returned. And of course, this can be performed by using a static lift function from our function class. Also, we can perform carrying easily on our functions. Carrying is a concept of representing functions of higher arities as functions of arity of 1, returning other functions and performing and changing the whole list of arguments into a set of calls on functions that apply them one by one. So if we have sum of function sum that accepts two parameters, we can perform carrying easily by calling carried function, and as you can see, it gets changed into function 1 that returns also a function 1, okay? So the first argument here on the left integer, will be applied partially if you try to apply, if you use this function now. So if you create a carried function, it's very easy to apply a partial application in such a situation. So as you can see here, we created a carried version of our function, then applied one of the arguments, and as a result, we got a function that instead of summing two integers, adds a 2 to the provided integer. Memoization is a very, very cool feature. If we are operating on pure functions, on functions that do not really mess anything around and always return the same values for same inputs, why actually bother with calculating those same values all over, when we could just cache those values and calculate them only once, and in the future just keep returning values from cache? Well, we could do this. This is what memoization is about. So in Javaslang, it's very easy to create a function, memorized function. We have just a memorized instance method. We can just call them, and we get a function that caches our results. And I have very, very bad example for this, because let's have a look here. I created a function of mathRandom. This is a very bad example, because mathRandom is totally the opposite of something that's referential transparent, because we are expecting it actually to return different results for every call. So let's try to memorize it. So we are creating a memorized version of mathRandom function, calling twice, and as you can see, in such situation, we will always get exactly same results. So I hope it's clear and that you like it. Also, the syntax for tuple is very, very easy to follow too. So if you want to like temporarily couple a few objects together, so in this example, it's something like a pair. Because we are pairing together two objects, we can create it by using static method of from a tuple interface. And what's really interesting, that of course it's immutable, but also it comes with a very rich API that you can modify it with. Oh, well, not modify, because modifying doesn't modify anything, but it returns a new instance instead. So we can modify like all of those tuple elements by providing mapping functions. We could also transform tuple into some other object by providing it the transform function with a function that takes as arguments all types of what tuple holds, and we could just basically squeeze as much as possible from polymorphism and return sequence that contains iterable that contains our tuple elements. Could be handy sometimes. Okay, and let's talk about value right now. Values in Javaslang are also all functional control structures, which are, for example, option, which you probably know from Java. This is the same as optional. We have try. Try is something kind of similar to optional, but instead of dealing with nullability of some objects, it deals with methods that could produce some exceptions. So you can put inside the try some function or operation that might produce an exception, and declaratively map it as just like with an optional, and the structure of a try will handle the situation where when exception was thrown or not. So at the end of our chain of operations, we end up either with a valid value that was returned, or with an exception that was thrown at some point. We also have lazy value, which is a class that allows us to create lazily initialized values. We have an either type, which is a nice way of dealing with return types that could be one of two types. We have future, which works pretty similarly to completable future that you know from Java. And the validation, which is a very nice way of dealing with object validation. And also, what's very important is that Javaslang is trying to squeeze as much possible from polymorphism. So the interface value actually extends an iterable. And because if you actually look carefully, you can look at any of those as containers that could hold 0 or 1 values. So this can be really handy. That can very simplify some stuff. Let me show you soon. And the very important thing that the whole new collections API by Javaslang is also extends value interface. So it's immutable and holds all those useful features that you can find in other those functional control structures. Okay, so when it comes to option, as you probably know from Java, you can put something inside and declaratively provide some actions that would need to be performed on the underlying value. And at the end of the whole chain, we can specify a default value that should be returned in case of the object is empty, the underlying value is empty. And in Java 8 we had some problems because if we ended up with streams of optionals, it became, well, not really very painful. But if you wanted to like pick only values that were present, you would need to either perform a very long chain of operation, like as you can see, stream filter map, and then eventually collecting everything to list again. But if you actually remember about the fact that optional is an iterable right now, why not just use a simple flatmap operation and reduce the whole stream and treat optional as a list? And in such case, you can perform simple flatmap and end up with a list only of values that were present in those optionals. When it comes to try, as I told, it's a nice way of dealing with exceptions. So if you want to use it, you just need to supply a try with a supplier of a new object. In this case, we'll be using new URI. As we all know, they like throwing exceptions. Then you specify declaratively operations that should be done on the underlying value. And finally, at the end, you can specify how can you handle the situation where exception was thrown. So in such case, we'll be just returning unknown string if something went wrong. Also, a lazy value. This is probably very intuitive. We are creating values that are based on some expressions that are evaluated in the last possible moment. So as you can see, it's very easy to create them because you have method lazy_off. This is supplied with a method that produces the result. And as you can see, we can perform mappings on those objects. And actual value everything will get calculated when we call get. When we are actually trying to reach this particular value. Also, let's talk about functional data structures. This is a concept known from functional programming and also present in JavaSlang. Functional data structures are special data structures that are persistent, immutable, and have referential transparent methods. As you all know, probably you can imagine what immutable data structures are. But there is also a concept of persistency, and persistent data structures are data structure organized internally in such a way that they can persist somehow the previous version of themselves when being modified. This allows to save a lot of memory because when you are copying lists, by modifying them, You are not creating a separate beings, but you can reuse already existing references. If you want to get to know more about this subject, I highly suggest you to check out Oleksiy Layev talk from Devox. He has like the full talk, conference talk dedicated only to functional data structures. Also, and now we have a second to have a look at sequence type tree in Javaslang. Actually, I wanted to point at one particular element of this. It's a stream that can be seen almost in the right bottom corner. The streams in Javaslang is something different than in Java. In Java, streams are kind of like an abstraction layer that allows you to just a form of a fancy iterator that allows you to perform some calculations and then repack everything into one of your collections. But stream in Javaslang is a 100% real collection. I mean, the data structure that can hold linear sequences. And what's also very, very interesting that most of those types here, they also try to squeeze as much as possible from polymorphism. And when you go up, when you traverse the whole type hierarchy, you will end up at some point and see that some of them extend functions. This can be very handy because basically if you look at a map or as a list, it can be seen as a kind of a function because map holds pairs two values together, pairs some inputs with some outputs, okay? So this could be basically seen as a form of a function, same with a list, because lists allow you to take some indexes and get some values basing on those indexes, okay? So this can be seen as a function. This can be very handy in some situations when you, for example, need to map one collection using another one. If you want to do this manually, it would be very painful. So this can simplify very many things. And don't worry, you are not supposed to see anything here. If you go to your favorite IDE and try to use Stream API, you will see that the API is really rich. I thought it was very rich. I thought I would never use those methods. But actually, after some time, you realize that that some methods are missing there. And before I go further, have you ever missed any particular methods from Stream API? This is the same question that was asked during the panel right away. Yeah? Okay. What's your name? Okay, Bogdan missed something in the API. Okay, I missed something in the API too. So basically, yeah. So, but this is the only one that missed something. So I guess the rest of you is very satisfied with the Stream API. So basically, if you open your code compilation tool in your IDE and you see Stream API, it's like this. But when you open it, the one from Javaslang, it's like this. So basically, in Javaslang, you have all possible methods known from Scala and from other functional programming languages, and all those are here. And basically, for all possible scenarios, they are there to help you. So, for example, what I really missed in Stream API is like these things by using some custom equals method. It wasn't possible to do. And here, if you traverse the whole list, you will see that you have methods like combinations that return all possible combinations of elements, cross product method that returns all possible cross products, and now we can do something like drop right, drop left, drop until. You can return head as a normal value. You can return head as an option. You can return tail as an option. You can intersperse. You can check if it's traversable. You can cycle streams. Not really streams, but all those types that could be actually cycled. You can cycle them by using for a limited amount of times. You can tuple them, perform normal for each, append something to a stream or a sequence, which was very hard to do actually in a Stream API. I mean, it wasn't really hard, but it was it could have been that much more easier. You can extend streams, filter them, flat map them, and many other options. So there is everything you will ever probably need. Okay, and you can do fancy stuff like this. This is a Fibonacci sequence, infinite stream of Fibonacci numbers, creating using those new tools. So as you can see, we can play with stuff like this. You can create stream of 2 ones, then append it with itself using function that zips it with its own tail and then adds 2 tuples together. Yes, this is difficult. Okay, so, and my favorite feature that was that's Javaslang managed to bring to Java is pattern matching. Pattern matching is like a very it's like switch case on steroids. So as you can see in this case, one more thing before we start. This is, of course, this might look very odd to you because this doesn't really look like typical Java code, but believe me, this is okay. Those are just static methods with with capitalized first letters. Well, obviously, we don't support Java doesn't support pattern matching on a language level, so it needed to be somehow overcame. So, as you can see, we can use match, put some value there, and then specify different cases it may fall into, and specify some particular results that should be returned in case the value was matched to a particular case. Of course, if we don't specify all possible cases, we can use a special method option that will help that will save us and return an option if the value wasn't actually matched. Of course, and what's very interesting that we don't really need to match using only predicates. We can specify the whole values. So when using cases, we can put values there, and if the value matches one particular value, the matching result will be returned. But it gets even more interesting because we can match not only whole values, but we can match those values partially. So let's have a look at the matching by using local date. And as you can see, in the first case, we are matching one particular date and returning string representation of it. But in the second example, we want to match only dates that happened in 2016. And in this case, we can use those dollar handles, dollar with brackets and dollar with an underscore. And as you can see, those are basically wildcards, but there is a small difference between them. If you use a dollar with brackets, you can use it for grabbing a particular value for using it to calculate the value, the matching value. So as you can see, here we are using dollar with an underscore, and this value is totally ignored. But when we are using a dollar with brackets, the latter function has this value as a parameter. So we can calculate our value basing on this grabbed function. This is similar, kind of similar to what we can find in regular expressions. And what's really interesting is that you can perform matching also using types. So in such case, basically option in JavaSlang and in Scala is only an abstract class. It has 2 subtypes, some and none. So if we would like to match all examples that have some values inside, we would use some, which is the subclass representing values, optionals that have something inside. We would put this wildcard inside and grab this value and calculate a result. And if we want to match cases where optional would be empty, we could use non-type. Okay, JavaSlang comes with many predefined predicates, so there is no need of writing this by yourself again and again in every of your project and creating predicate util class. So basically all of you can find like is in, any of, is instance of, is null, is not null, and stuff like this can be found there. Also here is like a more like real life example when we are matching command line parameters, and as you can see, you can check if they fall in 2 different categories. So this example should be much easier for you to follow because it is pretty much a real life example. And the one very important thing is that you don't need to use pattern matching in a standalone form. So when you are using options, tries, and other of those tools, or even collections API, you can use pattern matchings inside for performing some conditional calculations. So generally, that would be all. I hope that you like the JavaSlang, the stuff implemented right there. JavaSlang is not. We've been talking today about JavaSlang core, so this is not all. There are many more different modules that the community is working on. We have JavaSlang Match. JavaSlang Match is a library that allows you to create your own patterns for pattern matching. There is JavaSlang Test, a property testing framework. JavaSlang Pure for like very experimental math stuff. Circuit Breaker, there is module for with Jackson support for all those classes in JavaSlang, and JavaSlang Render. So I highly suggest that you should check them all up. And that will be all. Thank you very much. I hope you enjoy it. Definitely you should give it a try. Thank you very much. Do you have any questions? Oh, great. So,
great library for Java, for fixing actually Java 8. Do you have anything in JavaSlang that Scala doesn't have?
well, JavaSlang actually is a Scala-inspired feature. Okay, so it kind of brings all ideas back to Java. So you probably won't find much more than in Scala. This is it.
So what is the point of using JavaSlang plus Java instead of just pure Scala?
Okay, that's a good question. Let's do a social experiment maybe. How many of you is writing code in Java? Okay, how many of you is writing code in Scala? Write code in Scala but can't. Yeah, so basically JavaSlang is for you. Yeah.
I have more pragmatic question. So regarding the JavaLang, is there some performance stuff or some benefits inside the library, or only just the API that it provides? And another thing, it's like mixing these functional approaches with object-oriented style. It can make the code much more complex and etc. So what's the best way to use this kind of library regarding this?
Okay, so the first thing I'd like to address is that what's the main benefit? So obviously, except for getting code that probably will run at the first time or second or third, you get thread safety for free, because if you're operating on immutable values, there's always thread safe. And so you don't need to worry about synchronization, wrapping your collections into synchronized stuff and problems like this. So thread safety by default. When it comes to performance, there is a GitHub issue that aggregates all like comparisons and performs a benchmark. And when it comes to this, it's different. Some things are a bit slower, some are slightly faster, but generally I would not worry about performance issues, because it depends on one particular case. On a particular case, it's just like even with streams and for eaches. Sometimes for each is faster, sometimes stream is faster. So I wouldn't. It's not a trade-off. Okay, you are not sacrificing performance for the sake of a nice API.
I have a question about the lazy. Some feature of the Scala is called like call by name. Is JavaSlang has same realization by native? Not, as I understand, we can realize it by the lazy evaluation. And the next, what's about lazy over HTTP and serialization? Can we get method on the next site, and will it have the much more size of the bytes, or it can be evaluated correct?
Well, it's a very good question, and I don't know the answer for this. Yeah, I'm not the creator of JavaSlang. I'm one of the users, but it's a really nice topic. It would be really nice if you could bring it to like a GitHub issues and raise the awareness of this.
Okay, and what about the call by name native realization?
Well, as you can see, Javaslang is just a set of classes for Java. It doesn't change how language works. So when you are dealing with lazy, it's just a class that some in the constructor just defers the initialization. So any features of Java are not changed. This is just a nice implementation. And even when you want to use it, it's not like you have like a nice keyword that you use just like you have in Scala. You can't like just lazy something, lazy var or lazy val. But you just have a type lazy, which is a generic parameter, accepts one generic parameter, which just returns a value. So this is like a workaround, of course, but you are kind of limited to a language. You can't change it. You can just make it better by working by its rules.
Okay, thanks.
No questions? No.
Maybe a really short one. I saw that you mentioned the checked function that is supposed to throw the checked exception, right?
Okay,
right?
let me get back
I
to
mean,
that.
most probably you are wrapping to the runtime exception because I mean, you're not providing the exception type like argument to the function, right? So, but you are wrapping to the specific types of runtime exception?
Well, no. You can actually throw a check exceptions. You don't need to in this function. Let me get straight here. If you are dealing with a normal function, you need to wrap it into a runtime. But here, checked function, if you go into implementation, you will see that there is actually a throws clause. Okay, so it has, and I think there are few versions of this. There's a checked function that throws some generic exception, and I think there's a checked functions that have like a generic parameter that can be generified using a particular exception type. So yeah, there is no wrapping. You can get a normal check exception out of this without any particular magic.
Oh, okay. So
yeah, basically, this is what I was doing in our project, and I saw this being done many times. Because if you wanted to throw a checked exception in function, you would just define your own function with a that would look exactly like the one that you could be found in Java, but with a throws clause. And the funny thing is that actually in Talk we developed a library like this. We released it a long time ago, but this stuff got into JavaSlang, and now we ended with 40 stars on GitHub. But we are glad we don't need to use we don't need to add our projects to separate libraries, but only one.
I suppose it's mostly for people who are making the transformation to the functional programming from legacy code. So, tendency is that everybody is moving towards runtime exceptions, avoiding any checks. And another question about the lazy, actually, I saw that you've got the method like get that is going to be deprecated in the Java 9 from the optional. It's one of the examples. In the lazy.
Yes. Let me find it. I know what you are talking about.
Yeah. Are you checking for the
present
or something like that?
This is totally. This is
this one. Yeah.
This is a different get. Okay, this is different collections API, so you don't need to worry about it. You know, in Java, you have only like optional. You have only one functional control structure. You have optional, and if you remove this one, it's okay. I like it because there won't be like optionals used like normal values and that throw exceptions anyway. That translate null pointing exceptions into no value present exception. But here, get has some big higher meaning. Okay, it's some high up in the type hierarchy, in a value interface, or even higher. I don't remember. So well, you just need to use it responsibly.
Okay, but what does it return if I have no value coming from the application of those?
Well, you will always have a value because get in such case just triggers the computation, triggers the method, the initial method. So in such case, when you call get, it would call very long computation, then get this result, call toString on it, and then call toUpperCase on it. At the moment when you are calling get.
Okay, But the map suppose that you are getting the value, the return type, right?
Can you repeat?
Yeah, the map implies that you are getting the return type. You're getting something back. In the case you don't get anything. So, for example, the null.
Well, so
it's not restricted to the to string and to upper string case, I suppose.
Okay, so if you use those tools very unresponsively, and of course we didn't. There is no way of removing null from a language itself. So if you create a Verilog computation that returns
so
null,
you're getting the null pointer exception, something like that. So,
yes,
okay.
it causes a problem, obviously.
All right, okay.
But if you have something that can, if you have some computation that can cause null pointer exception calling at some point, I guess that you probably failed when implementing this, because you could have like done this with optionals and other stuff and not making this method return nulls. The problem is when you are using some existing APIs that you can deal with this. Yeah.
Right. I got it.
Another question there.
And you also can, if you are worried about the null pointer exception in this lazy computation, you can just wrap the lazy get with a try monad and like handle this case easily in functional style.
Yeah, yes, basically. You have all necessary tools for handling a null pointers exception. So don't. Okay. Okay, so I guess that's everyone. So thank you very much.